Good morning. Today we are going to see about compressive strength of concrete specimen. Methods as per IS 516. The size of specimen is 150 into 150 into 150 cubical specimen. The capacity of machine is 2000 ton. It is fully automatic testing machines. So in that machine consists of one LVDT. Also we have one adjustment, the pace. We can adjust the pace as per the code. We can fix the pace rate of the this machine. Also we have one more adjustment is that, so name of this screw is load release screw, load adjustment screw. The size of specimen is 150 into 150. If grade of concrete is M20 means, where M means the mix, where 20 is the characteristics cube compressive strength of concrete at the age of 28 days. So we are, if grade of concrete is M20 means, where M is the mix, where 20 is the characteristics cube compressive strength of concrete at the age of 28 days. So how to find the characteristics compressive strength of concrete at the age of 28 days? By means of cubical specimen. The size of specimen is 150 into 150 into 150 mm. As per IS 516, we are doing the compressive test of compressive strength of concrete is measured using this CTM compressive, especially CTM compression testing machine. The type of load acting is gradually applied load. It is a gradually applied load. So we can keep the specimen inside the machine. So it should be uniform because the stress distribution is uniform across the section. So we can keep the specimen in straight way. So without any frog patterns. That's why the stress will be distributed equally on all the sides. So after keeping the specimen, first you close the load wall. First you can close the load wall. So after that, so we have a LVDT attached to that machine. So you can start the machine using this button, start button. Already it is available in the machine. So after pressing start button again, you can press it, kickstart the LVDT. So the sound, the noise indicates the machine is running in right conditions. So how to find the grade of concrete means, so based on the force equal to stress by area. Based on that we are finding the compressive strength of concrete. So we are getting the compressive strength from that machine in terms of kilonewton. You know the area, load by area. Area of the specimen is a cubical specimen. Area 150 into 150. Based on the crushing strength and then area, we are finding the compressive strength of cube. So after that, as per code, so you can increase the pace rate. You can increase the, using this valve, you can gradually increase the speed of the machine using this. So in that LVDT we have many options. By default you can fix the dimensions. So without using any calculators, so avoiding the manual calculations, you can give the input of the size of the specimen in terms of mm or whatever you record. So in that machine we have the functions. Also you can fix the pace rate of the machine also. The sample size, instead of 150 mm 150, you can use 100 mm cube also. So mortar cube we are using the size 75 into 75 for finding compressive strength of cement. Compressive strength of cement means we are finding the grade of cement. For example, OPC 43, 53 and 33, where the numerical value 43, 33 and 53 indicates the compressive strength of cement. So listen, so the machine is running gradually. You can see the space between the cylindrical bar and it is reducing now. It is gradually it is reducing. So slightly you can increase the pace of the machine using this. So you can see the space between gradually it is decreasing. So it is fully automatic machine. No need to fix the adjustment any screw. You can't adjust anything. You will see the difference now. I think you will get the clear view now. So after touching, you will see the difference. You will see the difference in the load indicator. Now it is in 0. Now it is increasing, changing. The load is increasing gradually. So still it is taking load. Now it is 180 kilonewton. 180 kilonewton. You know the simple formula: stress equal to load by area, force by area. Yes. So now you will get the compressive strength. So maximum load is, the peak load is 182.4 kilonewton. Also the corresponding, already we fixed the dimensions, and then corresponding grade of concrete is, so you can calculate from the peak load. 182 point, convert this into Newton. Stress in terms of Newton per mm square, I am converting this into Newton. 182.4 into 1000, and then divided by the area of the specimen in terms of mm square, Newton per mm square. You will get the compressive strength of the specimen. Also you can see the crack pattern of the specimen. If there are two types, for example, the diagonal cracks mean it is a possibilities of shear cracks. So the corner. Once the specimen is failed, so we can remove the specimen from the machine. We can remove the specimen to thoroughly clean the surface. So you can keep another specimen here. You can keep another specimen here with the help of wire brush. You can thoroughly clean the surfaces. You can adjust these based on the specimen. Now you will see the failure. The failure, this depends on the grade of concrete, also the constituents. You know, constituents means the materials. It may be a C1, the conventional materials, C1, fine aggregate, coarse aggregate, and concrete. Instead of that, so if you are using fiber means it may vary. It may vary. It's purely based on the water cement ratio, and then the cement content, the quantity of cement content. And additionally, if you are using any mineral and chemical admixtures means the crack pattern may vary. So it depends on the mixed proportions and the water cement ratio. Also, so we found a compressive strength of one specimen. So as per Indian standard, we need 3 specimens. Average of 3 only we can get the grade of concrete, the M20, the compressive strength of concrete. Further, so the curing. The remaining specimens are available in the curing tank. So the purpose of curing means hydration, the chemical reaction between cement and water. So it is not simply spraying of water. The chemical reaction between cement and water. So normally we are taking, so after 28 days we are finding the compressive strength of concrete. So in that, instead of that, you can use the cylinder also for finding split tensile strength. And for prism, the size of prism is 500 into 100 into 100 to find the flexural strength of concrete. Also you can find the split tensile strength. Split tensile means it is an indirect tensile strength of concrete. So also you can find the flexural behavior of beams, so using some quantity of reinforcements. Okay, so that's all about the grade of concrete. So today we looked into the compressive strength of concrete. So then so also we got thank you.